Hey guys, welcome to another video here on the AviationPro channel. In this video we're going to take a look at how to start up the Boeing 737 next generation from cold and dark. Now I know that this is an old aircraft relatively speaking, and I know that there are already quite a lot of tutorials for this 737 out there. But you know, this is my favorite aircraft. I fly this aircraft a lot and I haven't covered it yet in my cold and dark series. So I thought, why not give a nice cold and dark tutorial, show you my perspective and the way I do it in this tutorial. So in this tutorial we'll cover both the cold and dark startup procedure and the FMC programming. And for the FMC programming we're going to simulate a flight from Innsbruck in Austria to Amsterdam in the Netherlands. So without further ado, let's head into the cockpit and start up this Boeing 737. Alright, as always, let's take a look at how to get the aircraft in the cold and dark state in the first place. And again, with PMDG aircraft it's very simple. Simply go to the flight management computer, go to PMDG Setup, load a panel state, and then NGX cold and dark is the default panel state to load the cold and dark state that I'm using in this video. So there we go. Now it loads up the cold and dark state. Alright, so welcome into the Boeing 737 cockpit. As you can see, it's fully cold and dark, and we're going to prepare this airplane for its nice flight from snowy Innsbruck to Amsterdam in the Netherlands. So again, I'm just going to take you through this step by step, and we'll take it easy. So first of all, what you want to do is get some electrical power on board the airplane, and for that we'll turn on the battery switch, which is located on the overhead panel right here. Just put it to on. There we go. Close the guard. And right now we can already see some lights popping up. The first FMC will be right now active. And what we want to do is arm the emergency exit lights. There we go. And what happens now is that the battery is supplying electrical power, so soon the battery discharge warning will come on, meaning that the battery is discharging. So we need some external power source in order to power the airplane. This could be the APU or the ground power unit. In this case I'm using the ground power unit, so I'm going to go back to the FMS, click FS Actions, and then ground connections, make sure the wheel chocks are set, and then connect the ground power. There we go. So I'm going to go back to the overhead panel and turn on ground power. There we go. As you can hear and see, some systems are starting to run right now and the battery is not discharging anymore. So soon the displays will come alive here on the main panel. The second FMC is now also alive, and there we go, the displays have been activated right now. What we're going to do is first of all go back to the overhead panel. We're going to align the IRS in order for these displays to actually show some information. So the IRS panel is all the way up here. Just move my view a little bit for you guys so you can see it better. So what we're going to do is put these IRS switches to nav, and what this is going to do is the inertial reference unit is going to align itself in order for it to determine its position in space. So as you can see, align lights have now been illuminated. So we're going to put this switch to heading and status. Right now we can see the time it takes for the IRS to align itself. So in this case 8 minutes. And we can go back to the flight management computer in order to set the IRS position. So we go to position initialization page. Last position is usually the best one to pick in this case, and then we're going to set the IRS position. Okay, so now the IRS is going to align itself. Alright, at this stage you could do some things like fire tests in order to make sure that all the systems of the aircraft are working and that you know, you have the appropriate equipment on board. So we can here test the APU and engine fire, for example. We can test the cargo fire panel right here. Just make sure every light is illuminated and you hear the bell ringing. Let's also set the parking brake, by the way. And what we also want to do is make sure that the lights are set to steady. So these are the lights at the end of the wings, the red and the green one. Allowing the ground crew to know that the aircraft is being powered. Don't put it to strobe and steady, that's only when you're on the runway. You just leave it on steady and the other lights can be off. If it's night, of course, you can turn on the billboard on the tail of the aircraft. Other tests that you can do is, for example, right here, you have the overspeed warning. You can test whether that function is working, and also the stall test. Right one is not working yet. You can here test the left stick shaker. Alright, so these are some of the systems that you can simply check. And one thing you can also do is make sure you do a light test, so you can see if all the lights are illuminated of all the warnings, so that all the warnings are being given to you properly. And you don't have to replace a light bulb. Alright, so let's go back to the overhead panel. I'm just going to treat it as always, like step by step, you know, as Boeing designed it, column by column. In this case we don't have to set up that much. Just make sure right here these are all the standby flight controls. All the guards are closed and the alternate flaps in the off position, and then turn on the yaw damper, which assists in turns and coordinates the aircraft in the air. Here we have the navigation and display switches. This is used to determine which displays use which kind of source for information. Well, in normal operations you just leave all these switches to normal and the source switch to auto. Okay, so you can just leave these switches as they are. Right here we have the fuel pumps panel. We're not going to turn on the fuel pumps yet because we're not using APU or engines yet. So if we're going to start the APU in a minute, we're going to turn on the aft pump of the #1 tank in order to supply the APU with enough fuel pressure. And then we can go to the next column. Right here we have the electrical panel. Just make sure that the cabin utility switches and the passenger seat switches are turned on, so you have electrical power in the cabin and for the passengers. Right here we have the standby power. Just make sure that the guard is closed and make sure that switches to auto, and you can just leave the disconnect guards closed as well. Here we have the generator panel. Again, we're going to use it in a minute in order to transfer power from the APU to the aircraft or from the engines to the aircraft when the engines are running, so we're not going to touch that. Then here we have the APU. Well, we're going to start it in a minute again, and the wipers, of course, you can turn them on during a taxi and flight. Next column we have the lights here of the circuit breaker panel on the back, and you can just adjust the lights accordingly if it's dark, of course. Equipment cooling, the switches should be on normal, as you can see, and the emergency exit lights we already armed at. And then we have here the seatbelt switches. Just make sure they're on, so passengers are boarding in a minute, so you can simply put on the seatbelts, and here the chime switch, you can use that accordingly, of course, to notify the cabin crew. Alright, so that's about it for this column. Then right here we have the window heats. You want to make sure that all the window heats are on, no matter the conditions. Just make sure that the windows are kept clean, especially in icing conditions. Probe heat, you know, these are the heaters that make sure that all the probes of the aircraft that measure speed and altitude are heated, so they don't become blocked with ice. We're going to turn them on after the engine startup. The anti-ice system, again, also something to consider for after the engine starts. So we're not going to touch that panel yet. And here we have the hydraulics panel. You want to turn on the hydraulics. You know, if you would do the walk around, you can make sure that all the systems are working fine. There are no leaks outside. For that, you need to make sure that the steering pin or the bypass pin has been inserted and that you get clearance from the ground crew to start hydraulics. Now in this case I'm using GSX to push the aircraft back, so I'm going to call up GSX, prepare for pushback and departure. Will not need the ice, and I'm going to push back to the left. Now let's just pretend that they've now inserted the bypass pin. That's not really simulated here in prepared, so we'll just turn them on, and this will power the main hydraulics. In a minute again the engines will be started, so they will take over the hydraulic power as soon as the engines have started. Alright, right here we have the entry door panel. You can see which doors are opening. Currently the forward entry has been opened, so we have to remember that we close that, of course. Right here we have the cockpit voice recorder and the cabin altitude instruments. You don't really need to touch them. Then here we have the air conditioning panel. Basically you can make sure that the trim air is on, so that air is being circulated around the cabin. And here you can also adjust the temperature as necessary. Recirculation fans should be both on auto, and the packs are off for now. Isolation valve is open for engine start, and all the bleeds are on. So as soon as we start the APU will provide bleed air to the air conditioning system. And then as we turn on the packs, air will run through the cabin. Alright, now here we have the cruise altitude and landing altitude systems, and this is used by the aircraft to you know, regulate the pressure of the cabin properly. So what we want to make sure is right now for Innsbruck, landing altitude has already been set. When we land at Amsterdam we can put it at you know, 0 feet pretty much, and right here we're going to put our cruise altitude initial cruise altitude today is flight level 380, and want to make sure that the this switch is set to auto, so that the outflow and the cabin pressure regulation is taken care of automatically. So that's a basic run through of all the systems that you can find on the overhead panel. Again, I always kind of like to overview all the systems so I kind of have an idea what each and every system does. And let's start the APU right now so we can supply the aircraft with air conditioning, because it's cold outside, you know, you want to make sure that the cabin is warm. Starting the APU is pretty simple. We're going to turn on the aft fuel pump on tank number 1. You can also hear that in the background. And then we're going to start the APU. Alright, so you want to monitor this gauge right here. In a minute the exhaust gas temperature of the APU will rise. It will go back a little bit, and then you know, this light will illuminate, indicating that the APU generator is available, and then we can let the APU supply electrical power. As you can see, the light has now come on. So instead of ground power, we'll now be using the APU to supply electrical power. And keep in mind that with the Boeing 737 this system is very tricky. If you would now release the ground power from the FS Actions menu using the FMC, you know, things will go wrong. The aircraft will not have a power supply. So always make sure that there's always some power supply on the bus, so to speak. So we're now going to put the APU generator on the bus. There we go. You can see the lights come off, indicating that the APU is now supplying the power to the aircraft. And you could put this switch to off. It will not, you know, disconnect the airplane of electrical power, because the APU is now supplying electrical power. So always make sure that, you know, especially if you're used to flying this 777 or the 747, always make sure you check out this panel in order to make sure that the right electrical system is powering the aircraft. Alright, so now that the main systems of the aircraft have been started, we can take a look at the FMC programming, which is always great fun. Now I've created a flight plan using PFPX that I will take next to the stuff that we're going to enter in the FMC. If you want a little bit more information on how to create a flight plan in PFPX and export it and then load it into the aircraft, make sure you watch this video of my VATSIM 2017 tutorial series. It should definitely help you out. First thing that you always want to make sure that you do is load the aircraft with the appropriate amount of fuel and payload. Now, of course, this depends on which add-on you're using. If you're using Zibo, it would be via the electronic flight back. In the 737 NGX, it will be via the FMS. Go to the FS Actions menu and click Fuel. Now, for this flight, I've calculated using PFPX. You can check the release fuel. As you can see, it's 6,368 kilograms, so I'm just going to round it up to 6,400. There we go. It's the total fuel that we're going to take on board, and as you can see here on the display, we have 3.20 tons in each wing tank, and the center tank is empty. So in a minute, when we turn on the fuel pumps, we'll not turn on the center pumps because we won't need them. And we're going to also enter the payloads. You could fill in the amount of passengers and cargo, or you could simply put in the zero fuel weight. And the zero fuel weight for today, as you can see on the flight plan, is 61,433 kilograms. So I'm just going to round it up again, 61.4. There we go. So now the aircraft has been loaded with fuel and payload, and now we're going to start with the actual FMC programming. Alright, so I'm just going to start with the ident page. We already covered that. We already entered the IRS position. The IRS is now aligned because you can see the displays. And we're going to go to route. So first of all, you want to put in your origin airport, which in this case Innsbruck, Lima Oscar Whiskey India, and our destination will be Amsterdam. There we go. Now we can put in a company route. If you've exported your route using a flight plan tool like SimBrief or PFPX, as you can see right here, you can simply enter the entire route for this flight by entering the code here. So in this case, I've saved the flight plan for this flight from Innsbruck to Amsterdam. So I'm just going to enter right here, Lima Oscar Whiskey India to Amsterdam 01. There we go. And it will instantly recognize this route, and you can quickly check on the navigation display, and indeed it seems to be all put in, so that works fine. Next you want to put in your flight number. In this case we're flying Transavia 16 Golf, that's our flight number for today. And what I also usually like to do is put that flight number here on the memory device. So in this case I could, for example, do 016, so I at least remember the first 2 digits of my call sign today. Okay, and then the runway, we're going to be using runway 08. There we go. Now, normally, you know, this would also be cross-checked by the first officer. You know, you really need to check everything twice. For now, I'm just going to activate this route and fill in the rest of the data. So what I usually like to do is already select a departure and an arrival. So for Innsbruck, we're going to fly from runway 08, and as you can see on the flight plan, we have the Kempton 5 Juliet departure. So I'm just going to select that and hit execute for now. And I usually also like to select an arrival for Amsterdam already. This is optional, you don't have to do that. You can just base that off the current winds at the airport, or maybe you can check flight radar where the aircraft are landing currently in the real world. So you can kind of determine what's going to happen. So I'm just going to select an ILS for runway 18 right for now. And we'll probably fly via the Norco 2 Alpha arrival and then via RTIP. Okay, so you really need to check the arrival charts. In this case I know Amsterdam well, so I know what the arrival route is. But you can check the arrival charts for your airport if you want to. But you can also do this during cruise, for example. Alright, so I'm going to hit execute for now. Alright, so right now the route is in there. We've selected the departure. You can check the lags page. Just make sure that you cross-check with the charts whether all the waypoints of the standard instrument departure are actually in there, including all the restrictions that you may have along the routes. Okay, and you can also check all the waypoints of the entire flight plan and optionally also the arrival. So go back to the route page, and then we have performance initialization. And this is a very important page. This is where you enter. This is why it was so important to put in the correct fuel and payload as in accordance with your flight plan. If there's any discrepancy right here, you're gonna have wrong takeoff performance calculations, and especially for a short runway like Innsbruck, it's vital that you have the correct information. Okay. Also, what you want to make sure is that your fuel units are in the same units as in your flight plan. So in this case, this aircraft uses kilograms. You want to make sure that you calculate your flight plan with kilograms as well. Same for all the other weights. Okay, now zero fuel weight, again we've already entered that while loading the aircraft, so you can simply click here on this line select key, and again, as in accordance with the flight plan, the zero fuel weight is 61.4 tons. You can enter that, and that adds up to the gross weight for today. So the zero fuel weight is the weight of the aircraft without any fuel. And since we have 6.5 tons of fuel on board, the gross weight will be 67.9. So that adds up very nicely. Then for the reserve fuel, I usually put here the alternate plus the final reserve fuel. So in this case, that's 1.1 plus 0.5 makes 1.6. And basically what this will do, the aircraft, when reaching this amount of fuel, will give a warning that you're using reserve fuel, and then you want to consider diverting to your alternate airport. Cost index is a measure for how efficient the engines are going to run. This really depends on the airline. I usually pick 30, and basically the higher the number, the less efficient the engines will run, and the lower the number, the more efficient the engines will run. So basically you will fly with a lower cruise speed. If it happens that you have a delay, you can put the cost index up a little bit in order to let the engines run a little bit faster, and that way you can speed up the flight, but of course it will be less efficient. Now, again, in accordance with the flight plan, we have a flight level 380. There we go. I may get some warnings right now for the arrival route, but we're gonna ignore that for now. Then we have the cruise winds. For that we have to go back to the flight plan. Basically what you want to put up here is the winds at the top of climb, allowing you to calculate the top of climb accurately. So in this case, on the flight plan, as you can see, the winds at the top of climb are 304 at 030. So 304 at 030. There we go. And I'm just going to ignore these warnings for now. And you want to put in the ISO deviation right here, or the top of climb outside air temperature. It depends a little bit on your flight plan format. In this case, you know, my flight plan states the temperature at the top of climb, so I'm just going to enter -51 right here. There we go. just ignore all these warnings for now. So minus 51 is the temperature at the top of climb, which deviates by 6 centigrades from the normal temperature at this altitude. That's what this ISA deviation states. You might also on your flight plan see something like P06 or M03 indicating plus 06 or minus 03, and then you put that in the ISA deviation. So instead of entering in temperature, an actual temperature at the top of climb, you may also see a plus or minus temperature indicating the ISA deviation. Next, you want to put in the transition altitude. You can find this on the standard instrument departure chart for, in this case, Innsbruck. As you can see, it's 10,000 feet, so I'm going to enter that. And this is the altitude at which you switch from the local QNH to the standard QNH. Alright, so 10,000. There we go. Just going to hit execute for now. Then we go to the next page, the N1 limit, and basically this is where you do your takeoff calculations and determine what amount of thrust you're going to use. Now you can do this using a tool like TopCat or maybe another performance tool that you may have. In this case, as you can see on the flight plan, we have a derated takeoff thrust with an assumed temperature of 30 degrees centigrade. So we're going to put in 30 right here, and keeping a look on the engine instrument right here, you can see that the N1 value for takeoff is a little bit reduced, as you can see. Right, so this is the best takeoff performance that we have calculated and are going to be using. And also for the climb, we're going to be having a little bit of a reduced climb thrust. And again, this saves the lives of the engines a little bit. Alright, then we're going to go to the takeoff page and we're going to put in our flaps. We're flying with flaps 25 takeoff today. And the center of gravity, normally you would get it from the load sheet, but in this case you can let the 737 determine itself what the center of gravity is. So it's 26.1, and we're gonna set that right here. And as you can see, the aircraft has now calculated some V speeds itself. You can also check the ones on the flight plan. You know, using your takeoff performance calculator, the speeds might be a little bit different, especially because your takeoff performance calculator might take into account the weather conditions and possible icing conditions in this case. So I'm just going to go with the ones in the flight plan. In this case, the speeds are very interestingly all the same. So 1 for 1, 1 for 1, and 1 for 1. There we go. And that will take us through our standard instrument departure. If there are any warnings, you just have to make sure that you check with the flight plan whether you are able to meet all the restrictions across the flight plan. Okay, so make sure, for example, during the SIT you're crossing this waypoint Romeo Uniform Mike above 4,700. If you're not able to, you might want to advise ATC. We're gonna go back to the route page, takeoff. Now all the V speeds have been selected. Basically, the main setup of the FMS is done. We can enter some more information. Just make sure you check the VNAV pages. Here we have climb. You can see all the different speeds and the restrictions. You don't really have to touch any of this. We can just leave it as it is. For the cruise as well, we don't really need to alter any data. In the descent page, you can put in the forecast. You can already maybe determine the transition level at your arrival airport. I usually like to put in something right here like flight level 60, because 180 is for the US only. So the transition level is determined by the ATIS here in Europe. So you have to listen to the ATIS in order to put that level right here, but it's not really of use right now. One thing we do want to enter based off the flight plan is by going to the route data page. So first to legs, then route data. We want to put in the average wind right here. So right now you can see here the value that we entered of the top of climb wind in the initial reference page. But in order to determine, you know, kind of the average wind for the rest of the flight plan, you can use the average wind calculation on your flight plan format. Now again, not all flight plan formats may have this calculation, so keep it in mind. In this case it does. So the average wind along the route is 309 at 027. If you don't have it, you can just leave it and just use the wind at the top of climb. Okay, but this is a little bit more accurate right now. We have the wind at all the different waypoints along the routes. Okay, there we go. So that's basically it for the FMC. I usually like to open the legs page on my side, and then on the first officer side I like to open the progress page so I can see how the flight is progressing. And now we can basically continue with the startup of the aircraft. Alright, so the way I usually like to do it when flying on VATSIM, for example, is first do the pre-flight checklist at this stage. So after I've programmed the FMC and all that stuff and the main setup is done. So let's do that right now. We have the oxygen. Well, we're just going to pretend it's tested in 100%. You would test it with this system right here. Navigation, transfer and display switches are normal and auto. Again, these are these switches right here. Make sure that they're in a normal position and auto. And then we have the window heat, which are all on, as you can see. We have the pressurization mode selector. That's just this little knob over here. Make sure that's on auto so that the pressure is regulated automatically. The flight instruments, you want to make sure that the altitude and the heading are correct. Now, in order to make sure that the altitude is correct, I'm going to kind of configure the EFIS panel, make sure it's in hectopascals. Current QNH should be 1008, and basically you want to cross-check all the instruments. So my display shows 1900 feet, the standby display shows 1900 feet, and on the first officer side as well. And you want to check the heading 169, 169, and you can also check the compass, make sure it corresponds to 169 heading. And that seems to be fine. And also then the standby instruments, make sure that it shows the same heading on all instruments. Okay, so the flight instruments, the heading is 169 and the altimeter is showing 1900 feet at QNH 1008. Alright, so that's been checked. Then we have the parking brake that has been set, and the engine start levers are these two. They have been set to cut off. Alright, so that completes the pre-flight checklist, and usually at this stage I want to ask my clearance. So when you get the clearance, you of course usually get a information about your departure. So in this case, let's pretend we've been cleared for the Campton 5 Juliet departure from runway 08, and that's exactly as planned in the FMC. So you want to cross-check at this stage, make sure that all the waypoints are correct so that you can fly this SID properly. And then also a squawk code is usually given. Let's pretend that our squawk code today is 3455, so 3455, there we go, enter that right here. And basically what you want to do right now is do your departure briefing, make sure that you know exactly what to do, what your procedure is during the engine startup, and while flying the SID. So when you do your departure briefing, you want to further configure the EFIS panel and the MCP, so you can adjust that to your liking. For example, you can arrange that on the captain's or pilot flying side we have the terrain display on. We're going to turn on the weather radar on the first officer side when we're reaching the runway. Make sure that the QNH is set. You can set some courses. In this case, as you can see on the chart, the inbound course to Campton is a course that we could enter right here. So that would be 323. And then we also tune the Campton VOR right here, 108.4. In the navigation radio. There we go. Then we have the speed. We want to make sure that we have the V2 speed right here. So 141. And the initial heading of the runway, which you can just also cross-check right here, is 079, as you can see on the FMC. So 079. And let's pretend that ATC has cleared us to an initial altitude of flight level 150. Okay, so there we go. And then on the first officer side, you can also put in your course. You could also, for example, tune an ILS or a localizer, in this case back to the airport. So in case you need to land at the airport again, you already have that ILS or localizer tuned. So 066, and then the correct frequency in here. So the reason why you would enter these courses and also tune these VORs or localizers is simply to get a little bit more situational awareness during the departure, and in case the FMC fails, you have the conventional navigation as a backup. Okay, so when that is done, when you're fully prepared for the departure and everything has been briefed and set up, you know, you kind of have to set up this all to your own liking and all the frequencies as according to what you need. So I can't really say that much about it. We can now go ahead with the startup procedure itself. And basically what we want to do is go through the overhead panel again, just column by column, make sure everything is set. We're going to turn on all the fuel pumps, first of all. Again, we don't need the center pumps if they're empty like now, or if there's less than 450 kilograms in the center tanks, you don't need to turn them on either. So just turn on the wing tanks, right like that. And this is all still set. The APU is running. It's fine. Let's make sure everything is okay right here. Yeah, seems to be working. Well, we should have maybe turned the packs on so we have some air conditioning on board the aircraft. We're going to turn it off in a minute again when we're going to start the engines. And I'm just going to turn the anti-collision lights on right here so that the ground crew knows that we're going to be moving soon and that we're soon going to be starting the engines. Okay. Now, what you also want to make sure is that you close all the doors and that all the ground connections are removed. So let's first do the doors. Close the forward entry. There we go. Remove the pitot covers. The ground power, again, just before you remove it, absolutely make sure that the APU is now on the bus. If it's not, the aircraft is going to lose power and it's kind of embarrassing. So make sure it's removed and remove the wheel chocks. And what's now going to happen, I'm going to go back to the lags page by the way. What's now going to happen, the pushback truck is going to get into position if you're using GSX, and we'll soon be ready for pushback. Now I always make sure that the pushback truck is fully ready to go before I ask my pushback clearance or before I do the before start checklist, because you know, when you are flying on VATSIM, air traffic controllers really want you to push back as soon as your clearance is given. You don't want to have to wait another 3 minutes in order for the pushback truck to get ready. So make sure that you do that. For now we're going to do the before start items and then the before start checklist. Just make sure that the hydraulics are on, make sure that the doors are now all closed. You can turn the packs off, alright, because we need all the bleed air from the APU in order to start the engine. So temporarily the cabin will not have air conditioning, okay? So keep that in mind. Again, the anti-collision lights are on. One thing you also want to make sure is that you set the trim right now. So we can just go to the takeoff page. The trim should be 3.88. So this is 4, this is 3, so it's already nearly there. Let's put it on 3.88. There we go. That's about fine for now. Alright, then we can go ahead with the before start checklist. The flight deck door is closed and locked. Well, you can just check that behind you basically. The fuel, we have 6.4 tons on board as planned, and you want to make sure that the pumps are on. In this case, all the wing tank pumps are on. Passenger signs are also on, as you can see, fasten seatbelts. The windows are locked, so you just want to make sure that the windows are closed. This is not simulated on this aircraft. Then you have to check the MCP. We have V2 141 speed set, heading is 079, and the altitude is flight level 150 as instructed by ATC. So you just want to make sure that the entire panel is set. You may also want to turn on the flight directors at this stage and maybe arm LNAV for the departure. Next we have the takeoff speeds, and that's why you have the init ref page open here as well. Just cross check with the flight plan and with the first officer whether it's correct. So 141, 141 and 141, all the same speeds currently. And go back to the lags page. The CDU pre-flight has been completed and we've programmed everything. The rudder and aileron trim are free and at 0. Well, you can check the rudder trim right here on the back. It should be reading 0, and the aileron trim is on the yoke basically. As you can see, you want to make sure that it's 0, and you can control that with the knobs right here. Knobs right here on the pedestal are the aileron trim knobs, okay? So you can use that to move the yoke in a certain position, but you want to make sure that they're all at 0. Taxi and takeoff briefing has been completed, we've reviewed that, and the anti-collision light is indeed on. Alright, so right now the pushback truck is ready. We've completed the before start checklist and the before start items. Right now you want to call up ground and ask for pushback. Okay, so let's say we've received our pushback clearance, we're ready to go. Upon releasing the parking brake, the aircraft will start the pushback. Make sure that here you have the engine page open on the MFD, the multifunction display. You can see you can open the system page or the engine page. Make sure you have the engine parameters running. And what we're going to do in a moment, as we start pushback, we're going to move the second engines. We're going to start the second engine, the right engine first. We're going to move that switch to ground, as you can see, and this will start the ignition process. And basically what's going to happen, the engine is going to start up. The N2 value is going to be rising. At 25% N2 we're going to add the fuel and then monitor all the values and make sure that the engine starts up properly. Okay, so I'd say let's go. I'm gonna tap the brakes and this should release the parking brakes. There we go. Well, I'm not going to do that. They say that because in the real world there might be a lot of snow on the ground, and you don't want to, start the engines in an area with a lot of snow, because you risk, pushing a lot of snow towards all the equipment and people on the ground. In this case, I'm going to ignore that warning, because we don't really see snow on the ground here. So I'm going to move the switch to ground, and this is going to start the engine process. So really closely monitor the values right here. As you can see, N2 is rising. We got a little bit of N1 rotation as well. And we're reaching 25% N2, and now we're going to put the fuel cutoff switch to idle. This is going to supply fuel to the engine. You want to make sure that you keep your hand or your mouse cursor on the fuel switch, because if something happens to the engine, you can quickly cut off the fuel in order to avoid the engine startup. Monitor all the values, make sure that everything is okay, and one value is rising, EGT is rising, everything is staying with limits. We have oil temperature rising, oil pressure rising, fuel flow is coming up, and as you can hear, the engine is starting up. 56% N2, approximately the engine start switch will cut off. And as you can see, the engine has now stabilized. Alright, the pushback has also been completed, so we're going to set the parking brakes, and then we're going to start engine number 1. Again, of course, you would ask the ground crew if it's okay to start engine number 1. But in this case, it doesn't really matter. So put it to ground. Again, monitor the values, make sure everything is okay. N2 is rising, we get some N1 rotation. And 25% N2, there we go. We're going to add the fuel. Again, monitor the values, make sure everything stays within limits. If something is not within limits, you will usually eliminate, and you will be notified, so make sure you keep a close eye. And the engine is starting up nicely. You can see right here we have the start valve open message. It means that the ignition is still working, and if you take a close look at approximately 56% N2, it will turn off. There we go. You can also hear it in the background. Alright, so we have 2 successful engine starts, as you can see. We can now open up the system page right here, but first we have to go back to the overhead panel, make sure everything is set. Alright, so what you want to do is first of all make sure that the engines are now supplying the electrical power. Again, on the 737 this is very tricky, so make sure the engines are now taking over. As you can see, those lights are now extinguished and the APU light has now been illuminated. It means that the engine are now supplying electrical power. So basically you can now safely turn off the APU without risking to lose electrical power. Alright, there we go. APU is off. Then just make sure it's all okay. We want to turn on the probe heats. We're going to turn on the engine NTIs as well in this case, because the temperature is below 10 degrees centigrade and there's also visible moisture outside. So you always want to make sure that before takeoff, after engine start, you make sure you have engine NTIs on. Wing NTIs is not used because it's only used to really remove any ice that's already on the wing. Okay, so that's all set. Then we also want to make sure that we turn on the packs. Isolation valve right here, I'll just zoom it in a little bit for you. It was open for the engine start, now we can move it to auto. And the other pack also to auto. Engine bleeds are supplying the bleed air right now to the air conditioning system, and the APU can be turned off. Okay, there we go. Now we want to put the engine start switch to continuous. What this is going to do is going to provide continuous ignition to the engine, so you don't have the risk of a flame out during the departure. Basically, when there's a lot of rain or a lot of stuff coming into the engine, there's a higher risk of a flame out. So by continuously having the ignition system active, the risk of a flame out is much less. Okay, now that's all set. I want to turn on the taxi lights for taxi, and then on the MCP you also want to arm the auto throttle. Okay, so as you can see, we're really following a flow right here. We're starting with the generators, then the probe heat, the NTI system, and then the air conditioning. Then make sure the engine start switch are continuous, and we check the MCP. Now we have the main panel. We're going to put the auto brake to RTO, And we're going to set the flaps right here to 5. Oh, sorry. We're going to set the flaps to 25 actually today. There we go. As you can see, the flaps are now coming down. Make sure you check this needle. Make sure that both the flaps on both sides are coming down properly. And as soon as that hits 25, we can make sure and check the flight controls. Okay. Now this is what I've seen from a cockpit video. I'm sure it's kind of different for every airline, but you just want to push the yoke forward, make sure that you have elevator deflection right here, and check the ailerons, left and right, and then pull the yoke back to check the upward movement of the elevator. That's also all been checked, and now we can check the rudder, left, center, and right and center. Okay, so the flight controls have now been checked. One thing I forgot to do actually was putting the transponder to altitude reporting off. Usually you want to do that before you start the pushback. Put that to altitude reporting off, and then once you are entering the runway, put the transponder mode to TARA. Okay, so that activates the TCAS. Alright, so that's basically it. The aircraft is now ready for taxi and the engines have been started successfully. Right now we can do the before taxi checklist. Basically, that's good to include that as part of this tutorial. So the generators are on, that has been checked. The probe heats are on, anti-ice as required, so the engine anti-ice is now turned on, as you can see. And the isolation valve, which was this little guy over here, has been switched to auto. The engine touch, which is continuous. The recall, you just want to push this button right here and check on both sides if anything stays illuminated. Well, in this case that doesn't happen, so the recall has been checked. Auto brake has been set to RTO. Flaps 25. The engine start levers are idle detent, which are these ones over here. The flight controls has been checked, and the ground equipment is clear. Okay, so right now you would be ready for taxi and able to continue your flight from Innsbruck to Amsterdam. Alright guys, I hope you enjoyed this tutorial here on the AviationPro channel. Again, the 737 is quite an interesting aircraft. Of course you see me fly it a lot on VATSIM, so you might also see me using these procedures quite often. But I really wanted to make this video because I think this aircraft simply deserves it. And again, there are many other great tutorials. If you want to have a more airline specific tutorial, I highly recommend to watch the tutorial about Flight Deck 2 Sim. It goes a little bit more in depth in regards to the procedures used at an airline, which is very interesting to watch, and it's using the Zibo mod Boeing 737, so definitely check that out. And of course you've seen Boeing cold and dark startups of me before. I think what's the most important thing about the 737 is the electrical panel. It really is very easy to forget that, especially if you've done a couple of 747 or 777 flights. It's all handled automatic. This is a relatively old design of an aircraft, which has its charm, but there are things that you may forget if you're very used to automated systems, like you would find on the 777, for example. So just keep that in mind. For now, I'd like to thank you for watching this video here on the AviationPro channel. Make sure you check out my Patreon page, patreon.com/AviationPro, if you'd like to support the channel. It would be very much appreciated, and really helps me in my effort to create educative videos for you guys. And I hope to see you on Saturday on the next video, in which I'll explain why I am not switching to X-Plane. Okay, so make sure you stay tuned for that, and I will see you next time.